Just wanted to say thanks to Jeff for inviting us down. It's the first time I've been to something like this, so it's a bit humbling, to be honest, with the calibre and size of everyone who's already spoken here.
It's a long way from
So thanks for inviting us down. So I just want to say, let me ask you all a question that you've probably taken for granted multiple times every single day. What's involved in making and keeping anything cold? I challenge you to find anything that you've eaten or had to drink today that doesn't involve or utilise refrigeration in some way. My name's Nathan Owens and I'm the operator and owner of Setpoint Refrigeration. I want to focus on the real world issues that we are facing in the refrigeration sector and highlight the ways we're looking forward and embracing those challenges, and then trying to look outside the box to be ahead of the game. Firstly, a bit about myself and who we are at Setpoint. Just to clear the air and save the same few questions later on, I'm 6'8", and yes, I play basketball. I live on the sunny Sunshine Coast with my beautiful wife Talia and nearly 4-year-old son Archie and 3 crazy Dalmatians. So life at home is pretty much just as hectic as at work with 6 employees and the phone ringing 24/7. But in all honesty, I wouldn't change anything. At Setpoint, we're about creating long-lasting, mutually beneficial relationships with our customers. And the biggest component of that relationship is doing what's best for the customer in the long run. We're all about developing properly planned, proactive solutions. We design and engineer and customise systems to be more efficient in the long run, and that's much better than trying to fix a freezer on a breakdown on a Sunday night. Gone are the days when electricity was just another bill, and gone are the days when no one really cared about how much it cost to run a cold room, a fridge or a freezer. So keeping those systems running more efficiently is crucial. We know that in some sectors, refrigeration alone accounts for up to 80% of their energy use. Our biggest challenge, however, is when making those changes, is to maintain the operational standards. That means not sacrificing the end product or the outcome just for the sake of using less energy. I mean, there's no point trying to save power if you're decreasing the product shelf life or its quality. Sure, there's lots of ways we can maintain the optimum performance and efficiency of the existing systems. Regular servicing is the most obvious. Preventative maintenance means small underlying issues can be caught and fixed up before they develop into costly or terminal breakdowns. Keeping the systems clean and serviced means they can run more efficiently. Remote 24/7 monitoring allows for real-time data analysis and energy optimization. Technology offers many options, from simple things like adjusting parameters remotely to pre-programming multi-system defrost schedules over a 7-day week. The benefits are really amazing. For example, we can use FridgeBot, to increase a cold room set point overnight between 6 p.m. and 6 a.m. when people aren't opening the doors and the product temperature is more stable. We also address how we actually read that temperature. Typical systems maintain air temperature set points by cycling the system on and off accordingly. But temperature can be very temperamental, heavily influenced by opening of doors or airflow changes. By installing product simulated probes, we can reduce the volatility and the reaction time of the controller's readout, and then create a more consistent and even cooling cycle. In one example at a large fish market, the freezer room system was constantly cycling due to the quick temperature spikes above the forklift door, even though the true room temperature was fairly consistent. We installed and averaged a probe in each corner of the room. 2 were product probes and 2 were air sensing probes, and then we used FridgeBot to manage it. The single probe originally had the compressor cycling every 10 or 15 minutes. However, with the new probes, we provided less frequent starts and short cycling, and then a much longer off cycle, even up to 90 minutes. Taking a step back and assessing operational trends and processes in a different way can often highlight inefficiencies and oversights that are easily rectified and then provide some big benefits. So what happens when things fail or a customer wants to expand or upgrade a system or a site? How can we start looking forward and planning for a better and greener system? Typical refrigeration systems are built for worst case scenarios. The hottest day, the highest humidity, hot product and heavy load. While important, those worst case scenarios probably account for around 10% of the true running conditions of the system. And then that leads to huge inefficiencies for the equipment. Large motors starting and stopping, fans running pointlessly, systems short cycling and adding unnecessary wear and tear on the equipment. We've started engineering and custom designing more appropriately sized units that have utilised smaller compressors, variable speed drives or VSDs, different refrigerants and EC condenser fan motors. This allows for a much wider range of capacity depending on the true load of the system, but actually delivers the same output with a much better energy profile and cost, which then in turn leads to reduced emissions. In simple terms, refrigeration systems just move heat or cold from one place to another. So the byproduct of making one space cold is the wasted condenser heat on the opposing side of the cycle, which you have to get rid of effectively. Typical air-cooled condensers and have large cooling fans which easily block or get restricted with dirt or dust. And the temperature of the immediate area is dramatically increased, which then impacts the performance and capacity of that exact system. So what can we do with this wasted heat? Just moving it away from where it's not wanted involves more fans, more costs, more outlays, more consumption. And it doesn't actually solve any problems, it just moves it. So we started thinking on the larger scale. What were the potential uses for this existing wasted heat energy, and how could it be stored or used? Discussions with Brett from BayRF and then Gary from EnergyFlex got our gears turning. Gary's EnergyFlex app provided live energy insights and tracking, Brett's engineering and forward-thinking approach, and our expertise and boots on the ground, and then direct customer contact, combined to look at a site's energy usage on a whole, and then also highlight areas of waste and poor management. Beefy's Pies production facility was the perfect initial case study. They're now owned by Retail Food Group, one of Australia's largest retail food franchise owners. So the stakes were high to make some improvements, but management were willing to give us a go and test our theories. Several factors were highlighted by Gary. First was load shifting, so basically trying to control or alter the electrical load of the site's usage to be more in line with the time or pattern. Baseline usage and peak demand was second. How can the site's peak demand be reduced or smoothed out? And then third was store potential. What or how can the energy be stored and then utilised in a more desirable time or place? I think Jeff touched on this earlier with another speaker, but the biggest opportunity was the stored potential in the customers' cold rooms and freezer rooms acting like a thermal battery. And then also utilising the wasted heat in a heat recovery system. The concept's not new by any means, but rarely used on a proportionally small scale. The design was simple: use the waste heat from the refrigeration systems to preheat factory hot water. Ultimately, we replaced 2 instantaneous hot water units and 3 storage units with a single standard hot water system plus the heat exchanger setup. At their previous electricity supply rate, the buyback period was around 2 years, but obviously with dramatic price increases recently, the buyback periods reduced significantly. Overall, we achieved approximately 18% reduction in energy usage, 40% reduction in demand charges, and a 30% reduction in water usage, all across the entire site. The demand charges were critical. BPs were on the verge of maxing out their supply transformer and had to decide whether to curtail production or move facility. Ultimately, controlling that peak demand allowed for a production increase without even moving sites. Stage 2 of this project was to further utilise the recovered heat mass for a defrosting of an embedded glycol evaporator system in one of their freezers. We eliminated the electric heaters and created a more effective and efficient defrosting cycle. The refrigeration system is in turn more efficient and the post-defrost recovery times much quicker. Stage 3 retrofitted variable speed drives onto the existing compressors, further reducing the peak demand. The pull down capacity was actually increased by allowing the VSDs to run faster than standard. So this is just one site. A couple of improvements of relatively small outlay that have had some huge overall savings. We're investigating new potential sites and opportunities with other existing customers and currently in the process of developing a computer modelling program to fine-tune and accurately predict the savings for any specific site. And I guess this is the whole point of my presentation and our plans for the future. We don't necessarily have to change and replace everything to be greener and then make a difference. We just need to take a step back and look at things from a different perspective. Assess, evaluate, adapt and improve. 4 simple steps that could improve thousands of businesses and millions of systems around Australia. Lots of small cost-effective improvements will be much more viable for the small to medium class sector, but still achieve the desired outcome of improving efficiencies and reducing emissions. I bet you'll think a bit more deeply next time you're eating a pie or having a nice cold beer. Thank you.